Welcome to this video on arithmetic operations and scientific notation. Let's begin. Below are some rules that we need to follow for performing arithmetic operations on numbers in scientific notation. Number 1, this is the most important rule. Do not convert the numbers to standard notation at any point in the process. This is what I mean. So for example, let's say you have the problem 2 times 10 to the second power times 3 times 10 to the third power. Now, it's true that you could convert 2 times 10 to the second power, you can convert it to 200. You could also convert 3 times 10 to the third power to 3,000. And then you could multiply these together. So you would have 200 times 3,000. This would give you 600,000, a number in standard notation that you would then have to convert back to scientific notation as 6 times 10 to the fifth. However, fair warning, if you do it this way, you will get 0 credit. Okay? That is not the point or the intention of this exercise. In many of the examples, you will see that the exponents will be something like 50 or 100. They're made deliberately large so that you cannot write all of those zeros on your paper. You cannot convert to standard notation. So be careful. Do not do that. Okay? What you should do is you should rearrange the values as needed, which you'll see in the following examples, and you should apply the product, quotient, or power rule to the powers of 10. So let's just make this sort of an example 0, even though there's more examples. So what should this person have done? Or what is the correct way to do this instead of converting it to standard notation? Well, remember all of these values, the 2, the 10 squared, the 3, and the 10 to the third power are all connected through what? Multiplication. And multiplication is commutative, meaning that the order doesn't matter. 2 times 3 is the same as 3 times 2. So what we do is we take our two mantisses, 2 and 3, and we put those next to each other. So now we have 2 times 3. Then we place our powers of 10 next to each other as well. So we have 10 squared times 10 to the third power. Now, we can actually just do the arithmetic here. 2 times 3 is 6. That's pretty simple. Then, we can apply the product rule to 10 squared and 10 to the third power. Remember, the product rule says if you have the same base, you can add the exponents. And 2 plus 3 is 5. So the final answer would be 6 times 10 to the fifth power. So hopefully you can see that this method of doing things is actually a lot faster than converting to standard and then back to scientific notation. Alright, so let's go ahead and do example 1. So notice the directions ask you to perform the following operations, and they say do not convert to standard notation any time. And we have to express our answer in proper scientific notation. So if you need to go back and watch my intro to scientific notation video to remember what proper scientific notation is. Okay, so step 1, as I said before, we are rearranging the furniture. We're moving things around to make it more visually obvious the steps that we can take. So I'm going to take the two mantisses, the 2.1 and the 3.7, I'm going to put those next to each other. Okay, then I'm going to put the powers of 10, so we have 10 to the negative 7th, and 10 to the fifth power, and I'm going to put those next to each other. Again, I haven't really done any math, right? I've just moved things around to make it more visually apparent what I need to do. So this would suggest that I could literally just type 2.1 times 3.7 into my calculator to get the result. And that's going to give me 7.77. So that's my second step. Now, what I can do is I can apply the product, quotient, or power rule. In this case, it's going to be the product rule. Remember, our product rule tells us that if we have the same base, we can add our exponents. So we're going to have negative 7 plus 5. Well, negative 7 plus 5 is negative 2. So then we have 7.77 times 10 to the negative second power. So then, before we circle our answer and move on to the next problem, we have to make sure that this is in proper scientific notation. And the definition is that our mantissa, 7.77, has to be at least 1, which it is, right? 7.77 is bigger than 1, and it has to be strictly less than 10. So is 7.77 strictly less than 10? And it is, okay? So we don't have to do step 4. There isn't an extra step because our answer is already in proper scientific notation. So we can circle it and move on. All right, the next example is 4.7 times 10 to the negative third power times 6.1 times 10 to the ninth. Again, the first thing I'm going to do is move things around, and I can do that because of the commutative property of multiplication. Okay, so I'm going to put the two mantisses next to each other. I'm going to put the two powers of 10 next to each other. And then I'm going to type 4.7 times 6.1 into my calculator to get an answer. So when I do that, I get 28.67 times 10 to the negative third times 10 to the ninth. Then I can apply the product, quotient, or power rule. In this case, it's the product rule, and since I have the same base, I can add those exponents. So I have negative 3 plus 9, which is 6. So I get 28.67 times 10 to the 6th power. So again, before I can consider this done and dusted and walk away, I have to ask myself, is my mantissa right here, is it at least 1, which it is, and is it strictly less than 10? Well, it's not, right? 28.67 is actually larger than 10. So this is not in proper scientific notation, so we have to apply step 4. So let's just take a minute and copy down the problem. So we have 28.67 times 10 to the 6th power. Okay, so what we're going to do is we're going to sort of ignore the 10 to the 6th power right now, and we're going to just focus on the mantissa, the 28.67. So if you recall in a previous video, we practiced taking numbers in standard notation and converting them to scientific notation. And we did that by saying, well, here's the decimal point, and then asking ourselves, where does this decimal point need to land in order for this number to be in proper scientific notation? So where would that decimal point need to land? Well, it would need to land between the 2 and the 8, because 2.867 fits this criteria of being between 1 and 10. So we would need to move our decimal point over 1 time. So this is going to be 2.867 times 10 to the something power. Okay, and then I'm going to bring this down as 10 to the 6th. I'm not really messing with that. Okay, so again, hopefully this makes sense. Okay, 28.67, we're treating it as just a problem inside a problem. We're converting 28.67 times 2.867 times 10 to the something power. Okay, so let's think about what this exponent should be. Well, we only moved the decimal point over 1, so our only choices are either 10 to the 1st power or 10 to the negative 1st power. So how do we know which one it is? So sometimes people think about moving it left, moving it right, moving the decimal point left or right, and that can get very confusing. Instead, all I do is I ask myself, 28.67. Okay, is this larger than $1 or is it smaller than $1? Which one is it? Well, hopefully we agree that if I gave you $28.67, I would have given you more than $1, right? So if this is more than $1, if it's larger than 1, that means you have to end up with a positive exponent. Okay, so that's the rule that I use, and that is easy for me to remember, and it makes sense to me. Okay, so now we can apply the product rule once again. So we're going to have 2.867, and then again the product rule tells us to add those exponents. So 1 plus 6 is 7, so we have 10 to the 7th power. And that's our final answer. Now this time we're going to do an example with division. Okay. The nice thing about division is it's kind of already visually sorted for us, right? The mantissas are together already, and the powers of 10 are together already. So we don't really have to rearrange the furniture, right? We don't have to do much work on this first step. But, you know, if you want to, you can kind of just transcribe the problem. It's up to you. Okay? So the first thing I'm going to do after I, rewrite it is I'm going to literally just type in 4.96 divided by 3.1. Just type that into a calculator. Okay? And that just gives us 1.6. No need to round, it's just 1.6. So we have 1.6 times 10 to the 4th divided by 10 to the negative 3rd. So now we're going to have to apply one of our exponent rules. So hopefully you can see in this problem we're going to apply the quotient rule. And the quotient rule tells us that if we're dividing two numbers like 10 to the 4th power and 10 to the negative 3rd power, then we have to subtract their exponents. Now this can be a little bit tricky because we have a negative exponent in the denominator. So it's not going to be 4 minus 3. That is not correct. Instead, we have 4 minus negative 3. Do you see that, right? Because it's 4 minus this number, 4 minus negative 3. And remember, minus a negative is actually plus a positive. So when we do this, right? We're going to have 10 to the 4 minus negative 3 power. Again, that's going to become 4 plus positive 3, or 10 to the 7th power. So again, be careful, watch those signs. The way I guard against sign errors is literally just by taking an extra second or two to write out the arithmetic. I actually write out 4 minus negative 3. Okay? So then, remember, we have to check ourselves and ask ourselves, is this in proper scientific notation? In other words, is the mantissa, which is 1.6, is that at least 1? And it is, right? 1.6 is larger than 1, and is strictly less than 10. 1.6 is definitely less than 10. So we don't need to do this last step. We're just done. So we can just say that 1.6 times 10 to the 7th power is our final answer. All right, let's do another example. So once again, we are doing division. So we are dividing 2.014 by 3.8. And then we're dividing 10 to the negative 3rd by 10 to the negative 7th power. So I'm going to type this into my calculator. And doing that gives me 0.53. And we still have the 10 to the negative 3rd power divided by 10 to the negative 7th. So now we're going to have to apply the quotient rule. So remember, the quotient rule of exponents says if I have something that looks like this, then I have to subtract my exponents. So we're going to have negative 3 minus negative 7. Remember, minus a negative is plus a positive. So we're going to have 10 to the negative 3 plus 7, which becomes 10 to the 4th power. And then I'm just going to transcribe my mantissa here for all of these. 0.53, 0.53, 0.53. There we go. Okay, so before we can, again, consider it done and dusted and consider that we're ready to move on to the next problem, we have to ask ourselves, here's our mantissa, 0.53. Is it at least 1? Well, it's not, right? It's smaller than 1. So we're going to have to do this extra step where we convert 0.53 times 10 to the 4th power to proper scientific notation. So here's where our decimal point is. Where does it need to land in order for this to become in proper scientific notation? Well, it needs to move over one spot so that it would become 5.3. Okay? And again, I'm just bringing down this 10 to the 4th power. So my big question here is, what is this exponent? Is it a positive one or a negative one, and how do you know? Well, again, you could think about moving it left or moving the decimal point right. I find that very confusing. Instead, I just say, okay, 0.53. Is that more than $1 or less than $1? Right? If I give you 53 cents, that's less than $1. If it's less than 1, then you know you're going to have a negative exponent. And that's how I remember which exponent I need. So now we can go ahead and apply the product rule one more. Well, we haven't used it yet, but we can apply the product rule here. So we have negative 1 plus 4, so that's going to become 3. So my final answer is 5.3 times 10 to the 3rd power. Okay, so in this last example, you might notice is not multiplication or division. Instead, what we're doing is we're raising everything to the 3rd power. We're raising 1.8 times 10 to the negative 4th to the 3rd power. So we're still going to rearrange the furniture, and what this is going to look like is that everything, both the mantissa and the power of 10, are going to be raised to the 3rd power. So let me write that out so that you can see it. So this is going to look like 1.8 times 10 to the 3rd power times 10 to the negative 4th power quantity to the 3rd power. So the arithmetic part is that I can type in 1.8 to the 3rd power into my calculator and evaluate it. And when we do that, we get 5.832, and again, we still have our power of 10 there, 10 to the negative 4th quantity to the 3rd power. So this time we are using the power rule. Remember, the power rule of exponents says when you have a power raised to a power, you multiply those two numbers. So we're going to have negative 4 times 3, which is negative 12. So our final answer is 5.832 times 10 to the negative 12th. And once again, we have to check our mantissa. Our mantissa is 5.832. And we have to ask ourselves, well, is this at least 1? And it is. And is it strictly less than 10? It is. 5.832 is less than 10. So we don't have to do this last step. We're all good.